Newton's laws of motion are among the most important ideas in all of physics. First introduced by Sir Isaac Newton over 300 years ago, these three simple rules still help us understand how objects move, whether it's a car speeding down a highway or a rocket blasting into space. Each law explains a different part of motion, why things start or stop moving, how forces affect speed, and how every action creates a reaction. Long before Newton, a Greek philosopher named Aristotle believed that things could only keep moving if a force was pushing them. So if a cart was rolling, he thought it would stop as soon as the pushing stopped. But in the 1600s, an Italian scientist named Galileo said something different. He noticed that if you let a ball roll on a smooth surface, it would keep rolling longer and longer. He thought that if there was no friction or resistance, the ball would never stop. This idea that things want to keep doing what they're already doing became the foundation for Newton's first law. Then in 1687, Isaac Newton wrote his famous book called Principia Mathematica, and in it he shared three laws that describe motion in a simple but powerful way. These three laws became the foundation of physics. Newton's first law states an object at rest will remain at rest and an object in motion will remain in motion unless acted on by an unbalanced force. The word inertia means that objects resist changes in motion. Imagine a book lying on your table. It won't move unless someone pushes it or lifts it because of inertia. Now imagine you're riding in a car. If the car suddenly stops, your body keeps moving forward, again because of inertia. The bigger or heavier something is, the more inertia it has. Newton's second law states the acceleration of an object as produced by a net force is directly proportional to the magnitude of the net force in the same direction as the net force and inversely proportional to the mass of the object. In short, this law is written as F equals ma, where F is the force, m is the mass, and a is the acceleration. If you push a small ball and a big ball with the same force, the small ball will speed up more because it has less mass, while the bigger ball moves slower because it's heavier. If you want both balls to speed up the same amount, you have to push the big ball much harder. Newton's third law states every action has an equal and opposite reaction. This means that when one object pushes on another, the second object pushes back with the same amount of force but in the opposite direction. For example, when a rocket blasts off, it pushes hot gas downward, and in response, the rocket is pushed upward. Let's quickly review. In the first law, things don't start or stop moving unless a force makes them. In the second law, more force means more acceleration, and heavier things need more force to move. And in the third law, every force has an equal and opposite force.